Hello everyone and welcome to Dr. Embalmer's channel of sorts. So yeah, today I wanted to take a look at this. It's the Klein Tools USB digital meter, USB type A, and no batteries required. Yeah, so this is basically a USB tester or diagnostic tool. And let's see what it says here on the packaging. I haven't opened it yet. We can monitor USB output, voltage, current, capacity, energy, and resistance. Qualcomm quick charge compatible. Current and voltage overload detection. 10 memory storage location. Bright, easy to read LCD screen. Okay. Drop protection 2 meters. Yeah, so okay. I mean, it looks rugged. Let's open it. And this is the model, let's see here, ET900. Or so it seems. Let's just try to get this opened. Yeah. Okay, let's see if that helped. Perhaps I was a bit too optimistic about this packaging. Yeah. Okay, I believe we have some progress. So, right. There we have it, ladies and gentlemen. Okay, so it doesn't work on itself because it says no batteries required, so I believe it draws power from the source. Let's see what it says here, if I can focus. Input 3 volts DC to 20 volts DC and 0 to 3 amps. Okay. Yeah. We have one button, one mode button. So let's see if it works. Alright, so the setup I had in mind. Let's just try it out. I have 2 power banks here. And this one has a display. And it will show both when charging and discharging how many milliamps is being drawn or fed into it. And yeah, we're gonna try to connect this in between then. So let's connect it to this one. Let's see here. I believe this one is, yeah, this is full. Let's see here. There. Yeah, so let's discharge this for a bit first. So we should connect it here. Okay, we have some output. 4.99 volts, 0 amps, 0 milliamp hours, 0 watt hours, 0 resistance. Okay, now this one cut off because the usage was too low. So let's start again. You can see that this one does not register any milliamp usage, so this doesn't seem to draw a whole lot of power. So now if we just connect this lead and start to charge this power bank, let's see what happens. Alright, we can see that this power bank, this large one, is blinking, showing it's charging. The USB tester also shows 4.94 volts and 0.4 amps. And we can see it's counting 3 milliamp hours so far and 0.022 watt hours. A measured resistance of 12.3 ohms. I suspect it's the resistance in the lead. I mean, this lead isn't very thick, so perhaps, yeah. And we have a timer that counts 1 minute now, yeah. So what does the other power bank show that we draw power from? So this one says 0.4 amps, right? Let's turn this one on. 420 milliamps, 420, 430. So yeah, this one shows 20 or 30 milliamps more than this one. But on the other hand, I suspect there is a chip in here of some sort that is being activated now with the display and everything, so perhaps all that is drawing around 20 milliamps. That shouldn't be too weird. But okay, 12.3 ohms. How about if I fetch another better lead here and we connect it and see what happens then. But we can also try to press the mode button and see what happens first. Nothing. If I hold it, let's see here. Memory slot 2, something blinks there. I believe it. Yeah, memory 1, memory 2. Yeah, okay, so we saved, in memory slot 1 we saved the progress then. And in memory slot 2 also saved, and then press it again and we see the current values. Okay, so when you hold it, you save like a snapshot of what you have. Fair enough. And if I activate M1 and long press, then I cleared it, it seems. Okay, but memory number 2 also got cleared, it seems. Okay, so it cleared the entire thing. All memory positions. Okay, so right. Let me fetch a better cable and we'll see what it says then. So now we have 2.3 ohms, it says. One moment. Right, and now I'm back. So let's see here. I fetched another lead, and as you can see, let's unplug this one. Yeah. So there is a difference in thickness of these ones. The black one is much thicker and stiffer. So let's try it instead. I mean, it is a bit longer than the white one, but I believe this should work better. So let's hook it up this way and turn this on. So what does it show now? 1020 milliamps we're drawing now instead of 430, 420. And this one is showing, yeah, 0.99 amps. So pretty much 1 amp plus the 20 milliamps or so that we had earlier. So the only thing we changed was the USB lead. But what does it say here? 4.91 ohms. That's a lot less than 12 point something that we had. And it results in a much faster charging rate. We see we have a bit of a larger voltage drop also, 4.87 volts instead of 4.95 or something. It's drawing more current, but I mean we have much lower resistance, so we're charging at a clearly at a higher rate at 1 amp. So yeah, and I mean this display is pretty neat actually. Let me focus on it. Yeah, it's readable from different directions. I mean, at the edges here, if I look from the left, from here, then yeah, the letters are pretty close to the edge, so you can see that, yeah, like this. But if you look, I mean, it's still visible from the sides as well. But looking straight on it, I mean, yeah, it's very readable. And all the characters are clear. We have backlighting. So let me turn the lights off. Let's see here. And focus on it. So yeah. Good display. I mean, it feels a bit rugged. And good diagnostic values here. We can see how much we have accumulated and charge in watt hours, and the resistance measurement is also pretty neat actually. I mean, it does show a different value between different cables, so whether or not the actual value shown is correct or not, I don't know, but I believe that if the value is lower between cables with the same device, then it is probably a better lead. So yeah, I mean, okay, I can understand that a lead like this, a cheap one, has higher resistance, it's much thinner, so there's not a whole lot of copper or aluminium, whatever it is in there. So yeah, let's reverse this whole setup then. We can see here that we're down to, let's see here, 89%, and we're steadily charging at a rate of 1 amp. So far 3 minutes in, so we're now down to 89% in this small power bank. Let's reverse the flow then. Let me disconnect this one from there and this one from here and refocus. Right, and then we will want to charge this small power bank like that, and let's see here, output up to 2.1 amps. Let's insert it there. Okay, it has started. But it's not charging. Let's see, turn it on. Yeah, now it's starting to charge. So let's see what it says. Okay, so we have the same setup with the same USB leads and everything, only now we're drawing power from this chunky power bank and into this smaller one. And okay, this power bank doesn't show the charging rate, only the accumulated milliamp hours, so we're up to 11 now, 12. So what does this one say? 5 volts steady at 0.7 amps. We have a bit higher resistance at 7 ohms or 7.2 ohms, 8 ohms. So that's interesting. We're almost double the resistance by just changing sort of the direction of charge. Let's insert this into the first slot instead. See what it says then. The same, 7.02. So yeah, okay. How about we change back to this flimsy cord. So remove this one and this one, and then we insert it here and there, and turn this on. Right. So what do we have here? Yeah, we're at 15 ohms, which is quite a lot, and we only reach 0.34 amps, 340 milliamps with this cheaper cord. So yeah, clearly it does have an impact. And using this USB diagnostic tester, we can clearly figure out which cords are good and which are bad. Sometimes you buy a thicker cord, but it's just more insulation around it and not much copper inside. And if you ever wonder why your devices are charging slowly, perhaps you can, with a tester like this, you can diagnose that and test the different leads and see what kind of difference it makes. And also on the power bank side, you can see if it holds the voltage at 5 volts or not. This was quick charge compatible, it says, but I'm not sure if I have a quick charge compatible device actually here, so I can't test it right now, but it should be compatible. I mean, then it should see other voltages, 9 volts, perhaps 12 volts. And also you can probably test some battery charging capabilities as well. So let's actually try a battery charger, and see what happens. Okay, so I found this little AliExpress cheap charging station, and it actually had also a USB lead. And this one, let's see here, we can focus. Yeah, this one actually has both a micro USB and a USB-C input. And we have a third lead. So how about at first we try to, let's see here, we can connect it with this third lead. Right. So we'll charge just this chunky one from the small one again. Let's turn it on. Yeah, 1060 milliamps. And now we're charging it just over 1 amp. 4.77 ohms. So yeah, basically this white lead and this thicker black lead, they're pretty similar. We had 0.999 amps on the black one and we have 1.0203 on the white one. So let's use the white one, since it's a bit higher in the charging rate. But instead of charging this chunky power bank, we could try to, let's see here, how can we clear this if we just press it long enough? Let's see here. No? Or do we have to disconnect it to zero it out? Okay, now this power bank cut off since we had no load. So now it will be cleared. So okay. It would have been nice to be able to clear it any time. But okay, let's connect this into this one. And then this charger charges in pairs. So let's insert a pair of batteries. Right. And then turn it on. Yeah, so now we have 15 ohms, it says. So perhaps this one also impacts, the charge itself impacts the resistance. And we're currently charging with 0.33 amps. Okay, so let me insert another 2 batteries. And yeah, we practically doubled the charge rate. So now we're, let's see here, at 650 milliamps. And we also lowered the resistance to 7.67 ohms. Yeah. And what does this power bank say? 660 milliamps. 630 here. So yeah, I got 20 milliamps difference, which might be the electronics in this USB tester that is drawing perhaps 20-25 milliamps. So yeah, great. Okay, but how about, I mean, this charger also has a USB-C port. So what if we remove this lead? Right, oh, sorry. And we bring in a USB-C lead and connect it. And then we connect it there. What do we have then? Okay. So basically we have this pretty much the same resistance. We have the same current draw, 0.63 amps. And this one says 650 milliamps. Also 4.91 volts. Yeah. Okay. Interesting. And how about if we change the power bank? We try to charge from this chunky one. Try the first one. Let's see here, I can focus. Yeah, same result, 7.92 ohms, 0.63 amps. Yeah, and let's change to the second port, the 2.1 amp port. Yeah, we'll get the same, 0.63 amps. Right, so these batteries are seemingly, according to this charger, they're pretty much fully charged. So maybe it's not a huge surprise that it's charging it. I mean, if they were empty, perhaps it would draw more current if the voltage would be lower across the batteries. I don't have any empty cells right now as far as I'm aware. But yeah, I mean, the focus is on this one this time. So yeah, so this is bought from Amazon. I'll put the link in the description below. And it's not an affiliate link. I'm just doing this for fun, so I want to share my experiences with the gadgets and stuff that I buy with you. So I like this one. It wasn't extremely cheap. I mean, it cost about $20 equivalent, perhaps. So there are definitely cheaper ones. There are AliExpress ones for like $1 or something, and I have those as well, but they feel so flimsy, and I wanted like a more rugged version. And of course, I mean, there could be perhaps other features as well. So yeah, let's see here. Now we have fully charged these two. So they were pretty much charged fully. And we're now down to 0.4 amps. Down from 0.63. So we're only charging these two now. So yeah. I mean, it's always nice to be able to test ports, for instance, on chargers, and when you charge your phone or pad or power banks, etc. It's always nice to see what's going on, and especially if you notice that something is charging slowly, or just if you're just curious, like I am also. So yeah, very neat little device. These are just the first minutes of using it. Like I said, I would like to be able to clear the accumulated values on the fly, but I will check the manual actually. 1 second. Yeah, so I checked the manual for a bit, and I found a couple of interesting stuff. So here it says, let's see here, I can focus down there. This tester will not display current below 50 milliamps, even if it is allowing this to pass through. The display will show zero current. So that's good to know that it's 50 milliamps at a minimum to actually show something. And also here it says, yeah, milliamp hours resets only when the source is disconnected. So yeah, it actually says so here. It would be nice to be able to clear on the fly, but I mean, it's not a big deal for me at least. So yeah, and right, great. Well, so this was it for this video. Thank you for watching, and hope you enjoyed it. Stay tuned for more upcoming videos. Thank you. Bye bye.